Hi, questions in optics. Here is a textbook for optics. Problem 4. A thick biconvex lens in air has an index of 1.810 and a thickness of 3 centimeter. Its first radius of curvature is 11 centimeter and its second is 120 centimeter. Question A. Determine the matrices R1, R2, T21, and A. Question B. A ray coming down toward the lens at an angle of 0.2 radians. As shown, contacts the front surface at a height of 1 centimeter above the central axis. 1. Find the angle of the reflected ray at the first surface. 2. Find the height at which the ray meets the signal interface. 3. Find the angle of the ray leaving the lens. Problem 4. Part A. The matrix R1 is given by this one. We know these values. So, we find that R1 is given by this one. The matrix R2 is given by this one, and we know all these values. So, we find that the matrix R2 is given by this matrix. The matrix T21 is given by this one. We know these values. So, we find that the matrix T21 equals this one. Then, the system matrix A given by R2 times T21 times R1. So we can find the matrix A equals this one. Part B. 1. We have this formula. So the angle of the reflected ray at the first surface is given by alpha T1 equals this one. 2. The height at which the ray meets the signal interface is given by this formula. This equals this one. 3. We have this formula, and we know these values. So the angle of the ray leaving the lens is given by alpha T2 equals this one. This figure shows the ray diagram for this problem. Problem 5. A thick biconcave lens n equals 1.5 has radius of curvature with magnitudes of R1 equals 10 centimeter, R2 equals 5 centimeter, and thickness D equals 1 centimeter. Find the effective focal length of the lens. Determine the image location and the image size when an object of 1 centimeter height is located at a distance of 10 centimeter from the vertex of the lens. Sketch the lens and indicate the locations of the principal points. Problem 5. The effective focal length f is given by this formula. This equals this one. So we obtain the effective focal length f equals this one. We see that SO is given by 10 plus H1, where H1 is given by this formula, equals this one. So we obtain SO equals this one. Then from the length formula, this one, we get SI equals this value. We have this formula. So the height of the image yi equals this one. The image location is given by Li equals Si plus H2, where H2 is given by this one. So the image location from the vertex of second length is Li equals this one. The length is illustrated by this figure. Thanks for watching. Bye.